Day 342 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1721, swapping nodes in a linked list. The difficulty level is medium, but don't worry, you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given the head of a linked list and an integer k. Return the head of the linked list after swapping the values of the kth node from the beginning and the kth node from the end. The list is one indexed. All right, y'all, that sounds simple enough, but sorry, y'all, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input head is a linked list 1, 2, 3, 4, and 5, k equals 2. That means we want to swap the second node from the beginning with the second node from the end. So the output becomes 1, 4, 3, 2, 5. So let's go ahead and just look at this picture here so we can get a better understanding of what's going on. So as you can see, k equals 2. So the second node is 2, right? And then we also want to swap. So we want to swap the second node from the beginning. Excuse me, the second node from the beginning is 2, but we want to swap the second node from the beginning with the second node from the end. So when we count back from the end, we go 1, 2. So the second node from the end is 4. That means we're going to swap this 2 and this 4, right? So after we swap this 2 and this 4, we get the new linked list of 1, 4, 3, 2, 5. And as you can see, all we did was swap this 2 with this 4 because the k equals 2. So on a 1 index, meaning that we started from 1 instead of starting from 0, and we just swap them. Yeah, simple enough. But let's go ahead and take a look at example 2 where it's a little longer linked list, but the principle is the same and the principles still apply, right? So in example 2, we have the input head equals a linked list 7, 9, 6, 6, 7, 8, 3, 0, 9, and 5. This time k equals 5. So that means we want to swap the fifth node from the beginning with the fifth node from the end. So let's go ahead and see what nodes that would be from a 1 index. So remember, we're starting from 1, not 0. So it goes 1, 2, 3, 4, 5. Boom. So we want to swap this 7. Then let's go backwards so we can see what the fifth node from the end is. We have 1, 2, 3, 4, 5. Okay, so we want to swap this 7 with this 8, right? Because 7 is the fifth node from the start and 8 is the fifth node from the end. So in the output, we get 7, 9, 6, 6, 8 because we swapped the 7. As you can see up here went 6, 7, but down here it goes 6, 8 because we swapped the 8 with the 7. Then it goes 7, 3, 0, 9, 5. And this is the output when we swap the fifth node from the beginning with the fifth node from the end in this linked list. Boom. So that sounds simple enough, y'all. So let's go ahead and get into the fun part, the actual solution, y'all. And the solution is not that difficult either. So let's get started. Now, the first thing we need to do is we need to create a variable that's going to track the length of the list as we iterate. So to do that, we could just declare a variable. We could call it len. And we could set that equal to 0 just to start. Now we need to create another variable that will point to the kth node from the start, and we need to create a variable that will point to the kth node from the end. So to do that, we can declare a variable. We can call it LHS, and we'll say colon. It's going to be a list node. Sorry, y'all, list node. And we put a question mark right there, and that is going to point to the kth node from. Eventually, it will point to the kth node from the start. Now we need to do the same thing for the end. So we declare a variable. We call this RHS colon. That's going to be a list node, and this eventually will point to the kth element from the end. Now we just need a pointer to traverse the list. So we can declare another variable. We call it node and set that equal to, oh, sorry, y'all. We can set that equal to head. Boom. Now it's time to iterate. So we can say while node exclamation point equals nil. So while node does not equal nil, we could say len plus equals 1. Then once the RHS starts moving, we need to advance it in sync with the node. So we can say if RHS exclamation point equals nil, so does not equal nil, that's what that exclamation point means. We're going to say RHS equals RHS question mark dot next. Boom. And then when we reach the kth node from the beginning, we need to capture the kth node from the start, and we need to start RHS from the beginning to track the kth node from the end. So to do that, we come underneath this if. We're going to start another if, and we are going to say if len equals k, or two equal signs k, meaning we've reached the kth node. Now we need to capture the kth node from the start, so we could just say LHS equals node, and we need to start the RHS from the beginning to track the kth node from the end, so we could say RHS equals head, just like that. Now we need to move to the next node, so we come underneath this if statement, and we could just say node equals node question mark dot next, just like that. Now after the loop, LHS is going to point to the node from the start, to the kth node, LHS is going to point to the kth node from the start, and RHS points to the kth node from the end, and now we need to swap their values. So to do that, we're going to come right here. We're going to say if let, we could call it val L equals LHS question mark dot val, comma, let val R equal RHS question mark dot val. We're going to open up the brackets, and we're going to say LHS question mark dot val equals val R, and RHS question mark dot val equals val L, and that's where we're going to swap them just like that. Now we still need to return the modified linked list, or the modified list head, so we're going to come right here, or come right here underneath this, and we're going to say return head. Now that should be all she wrote, y'all. Trying to see. Oh, sorry, y'all. This right here, we're not done. Sorry, y'all. This right here should come right here. And then we could take this right here and put it right here. So this right here should come outside of the while loop. It should be outside of the while loop, not inside the while loop. So now let's go ahead and give it a run. Make sure it runs properly before we submit it, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Okay, 22 milliseconds beats 85.37% of users. Not bad, not bad at all. We could get those numbers up. You know, I like to see that 100% right there, but that's okay. We'll take the 85 for now, because right now we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that, y'all, that everybody can learn from. So with that being said, make sure y'all get one more look at the code. Make sure you got everything. Read it, learn it, love it, internalize it. Make sure you understand how it works and what's going on. So this is the top half. This is the bottom half. And then with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.